Hello and welcome back to Building Tables. So this is the second example. If you see the first video, we went through how we want to make our table look like page 7 of the data booklet provided in the Alberta's curriculum. When I'm building my table, again, I want it to look like the data booklet. So my goal is to get my OAs on the left and my RAs on the right. And your data booklet on page 7 always shows reduction reactions. So going over if you see products, you know you have a reaction, so your OA is higher up than on the table than your RA. If you have no reaction, that is non-spontaneous, so your RA has to be higher on the table than your OA. So we're going to be going through and taking a look. Your OA and RA are always reactants. Products just help you see what's happening. So here your AM went from 3 positive to no charge. So to get that, you have had to gain electrons. And again, we use oil rig. Reduction involves gain. If you're gaining electrons, you're an oxidizing agent. NO is going from no charge to positive 2. That means it had to lose electrons. So that is oxidation. So NO is an OA. So when you go to make your table, your NO needs to be higher up on the table. Oh, sorry, I think I just got that. That's an RA. I'm sorry about that. So that your OA, AM has to be higher on the table than your RA, NO. Now, if you look at the next one, it's the same kind of setup. Ta3 positive had to gain electrons to become Ta, so that is an OA. AM had to lose electrons to become 3 positive, so that is undergoing oxidation, making this an RA. Now, AM is on the table from before, so we can just fill it in its reducing agent once it's gained electrons. And that's already on the table. And if we see products, we know the OA is above the RA. So now we can place TA higher up than your RA. So I'll place TA just a little bit higher now, and that would turn into TA solid. Now in class, I do say, like, we're doing this quickly. We do know electrons are here. If you want the full table, then go ahead and add in your electrons. But if you're just trying to get the OAs and the RAs ranked, then you don't need to worry about that. I can also put the NO's counterpart down here for the OA. Now this last one, when we're taking a look, sorry, I just moved down a little bit. This last reaction, says no reaction, as we talked about already. That means that your RA is higher than your OA. It's non-spontaneous. So we'll have to just assume what's happening. So Ta3 positive, again, it would want to gain. Positive charges want to gain electrons. So reduction involves gain, so that would be an OA, making the other one an RA. Now, my chart here, I don't have enough room, but that means my Ti is higher up than the Ta3 positive. So now that I have everything placed, when it's asking about the weakest reducing agent, reducing agents are on the right-hand side, weakest are on the top, strongest are on the bottom right. So my weakest reducing agent has to be A, which is Ti, or that's probably TL. Sorry about that. I think this last question is a good one to go over because it does come up quite often in a diploma style question. This is actually an old diploma question. And this question is giving you a list of solutions or compounds in solution, aqueous solutions, and it's asking what should not be stored. If you are not to be stored in something that is tin plated, that means your tin is your SN solid. And if you're not stored, you don't want to, if you're using it to store, you don't want it to react. So if it should not be stored, that means it would be reacting. So you're looking for always higher up on the table than your RA. And tin, this one here, would be your RA because it's on the right-hand side of page 7 in the data booklet. So you would be going through this, and if it's ionic compounds in solution, you can break it up. The ion you would be looking for here is Na positive. Here is Ag positive. This one here is SN2 positive. And the last one is the chlorine ion. So going through page 7, when I'm taking a look, I'm just going to open this up and I will show you in a moment. You would locate tin solid and then find the ions. So we're looking at tin solid, and maybe I can just move the phone for now. Tin solid was right here. So number 1 would not be a choice because sodium ion is down here. So that one would not react anyway, so it could be stored. If you're looking for Ag positive is up higher up, and so that one we don't want to store because that one would react. So number 2 we wouldn't store. Then you have tin 2 positive, so you might find it before me here. And of course, look, it's right here beside the solid. If it's beside each other on the table, it's not going to react. So tin can be stored in its own container, or the ion could be stored in its container. And now chlorine is way up here. Chlorine is above tin, so if it was in there, it would react. So your answer to this one would be 2 and 3, which is D. I hope you found that helpful, and I'll come back tomorrow with predicting redox reactions. Thanks for watching. Bye.